Good day, students. Today we will be looking into SNI reactions. SNI reactions. SNI reactions known as substitution nucleophilic internal reactions. This sort of reactions can be explained using an example of alkyl chlorosulfite. How alkyl chlorosulfite is formed? Alkyl chlorosulfite is formed by the reaction of an alcohol with thionyl chloride, and what you get is RO S double bond O Cl. This is alkyl chlorosulfite. The byproduct is HCl. What is happening? It will be attacking at this position, and one chloride ion is being removed. Here the reaction occurs in such a manner that this alkyl chloride sulfite will exist as an intimate ion pair. Alkyl chlorosulfate, which exists as an intimate ion pair, undergoes rearrangement in this manner. This is an intimate ion pair. And what will be formed? Alkyl halide and SO2 will be formed. Here what have here the substrate for SNI reaction is alkyl chlorosulfate, and alkyl chlorosulfate exists as an intimate ion pair in which the part of the leaving group attacks the substrate by detaching itself from the rest of the leaving group. That is part of the leaving group. Which is the part of the leaving group that is attacking here? Cl minus attacks the substrate by detaching itself from the Cl minus. This is the part of the leaving group that attacks the substrate by detaching itself from the rest of the leaving group. That is, the Cl with a pair of electrons, that is the Cl minus, attacks the R plus from the same side of the carbocation from which OSOCl is departed. The Cl with the pair of electrons of the anion attacks the R plus, that is the carbocation, from the same side of the carbocation from which OSOCl is departed. And the product, if it is attacking from the same side of the carbocation from which the leaving group is departed, then there will be complete retention of configuration. There will be complete retention of configuration because the attack takes place from the same side from where the leaving group is departed. So, SNI reaction gives complete retention of configuration. But in the same reaction, if a tertiary amine is present, tertiary amine example is pyridine. If a tertiary amine is present in the same reaction, then RCl which is formed is said to have undergone inversion of configuration. RCl will undergo inversion of configuration if a tertiary amine is present. So, the mechanism happening is something different. Here the pyridine coordinates with the HCl produced during the formation of the chlorosulfate ion. Here the pyridine coordinates with the HCl produced during the formation of the chlorosulfite from ROH and here this HCl. Pyridine coordinates with HCl produced during the formation of alkyl chlorosulfite from alcohol and thionyl chloride. And when pyridine coordinates with HCl, what will be formed? You will get pyridinium hydrochloride. Pyridinium hydrochloride is formed. And in pyridinium, when it comes to pyridinium hydrochloride, the Cl minus is an effective nucleophile, and the displacement of chlorosulfate ester by Cl minus via SN2 takes place with complete inversion of configuration. And the reaction of alcohols in the presence of thionyl chloride, the reaction of alcohols with thionyl chloride in the presence of pyridine is known as Darson's procedure. Darson's procedure. Darson's procedure. So let us look into the mechanism once. If you have a species like this is the exception of pyridinium hydrochloride that I am talking about. You will have pyridine, and what will happen initially? The lone pair of electrons on oxygen will attack on the sulfur, and the Cl minus will be eliminated, giving rise to the you will get the alkyl chlorosulfate. And what we have along with that, you will have the pyridinium hydrochloride. And in the next step, what is happening is, next step, or in this intimate ion pair itself, we can't say this as an intimate ion pair, sorry. In this step itself, what will happen is that this is the same thing. This is the pyridinium hydrochloride, and here the chloride ion attacks from the back side, giving rise to the leading to the leaving of SO2 and Cl minus. So since it is attacking from the back side, we can call it as an SN2 reaction. It's attacking from the back side. This will be the product. So we have been talking about SNI reaction. SNI reaction is substitution nucleophilic internal reaction, in which the nucleophile is attacking by departing from the leaving group, so that it attacks at the same side from which the leaving group is departed, leading to the retention of configuration. But in the same reaction, if a pyridinium hydrochloride, if some pyridine is added, or if some any other tertiary amine is added, then the stereochemistry of the reaction will be reverted. That is, it will lead to an inversion of configuration, like as we do it in a SN2 reaction, and it is called Darson's procedure. Here the nucleophile will attack from the back side, so that the leaving group departs. I think that is enough for now. Thank you.